All right, this is pages 1 and 2 for the probability 2-day review. So you're going to do this review over 2 days, and I'm going to give you answer keys 2 pages at a time, so the videos aren't too long. All right. Number 1 says Chris is going to toss the penny 3 times. We're going to draw a tree diagram, find the number of outcomes, and list the sample space. Find the probability of each outcome. All right. So the first toss, when you draw a tree diagram, you are writing down what you could possibly get, or the sample space here. That's the heads and tails for the first toss. On the second toss, it is also heads and tails for each. And then the third toss is zoom in, so easier to write heads, tails, heads, tails. Right. Duplicate that. Boop. Right down there. So that is our tree diagram. The amount of outcomes you could find by doing 2 times 2 times 2, which is 8, or count the right side of your tree diagram. I'm going to list the sample space starting at the top. That was a heads, and a heads, 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 tails, heads, tails, heads, heads, tails, tails, and tails, heads, heads, tails, heads, tails, finally tails, tails, heads, and then tails, tails, tails. Okay. What does HHT stand for? That is heads, heads, tails. Okay. What is the probability he will toss exactly 2 tails? So I'm going to go through and highlight every time there's exactly 2 T's. There's 1, there's 2, there's 3. So there are 8 possibilities. So the probability he'll do exactly 2 tails was 3 out of 8. What is the probability of flipping tails at least twice? So the 3 that I have already, at least, means there could be more. So there's 1 more. That would be all 3 tails. So probability of at least 2 tails is 4 out of 8, or 1/2. Okay. We're going to do a 6-sided die. We're looking for the fraction, decimal, and percent. So 1 or 2, add those together, or 2 of those out of 6 possibilities. That's the fraction. That decimal is 0.3 repeating. That percent is 33.3 repeating percent. Even, that's 3 out of 6, or 0.5, which is 50%. Prime. 1 is not a prime number. 2 is a prime number. 3 is a prime number. So is 5. So 2, 3, and 5. That is also 3 out of 6, 0.5, or 50%. Okay. There are 3 blue gumballs, 3 white gumballs, and 2 orange gumballs. What's the probability of getting blue? Before I do that, I'm going to add 3. 4 plus 3 plus 2, that is 7. That is out of 9 total. So the blue, probability of blue, are 4 out of 9. The probability of not white, okay, so if there's 3 white out of 9, then out of the ones that are not white are 4 and 2, 6 out of 9. Probability of black, I didn't see any black. That is impossible, or 0 out of 9. Okay? Out of blue, white, and orange gumballs, which is the most likely to be chosen? Blue, white, or orange? Blue has the highest probability. Say blue has the highest probability. Okay? A candy jar contains 5 red, 4 blue, 2 black jelly beans, and 4 orange jelly beans. What is the probability with replacement? That means this is independent probability. Independent means the probability doesn't change from one to the next. That the first jelly bean will be black and the next will be blue. Again, start by adding 5 plus 4 is 9, plus 2 is 11, plus 4 is 15, so they're out of 15. The first will be black, so black is 2 out of 15, and the next will be blue. blue is 4 out of 15. All right, so what we have is 8 out of 225. Okay. And we just said it out loud. This is independent because it goes with replacement. Okay. There is sports equipment in a sports box. There are 2 kickballs, 2 basketballs, 3 baseballs, and 2 tennis balls. What is the probability without replacement? So that is an important one, without replacement, of randomly selecting a baseball, then a kickball. Okay. So without replacement, that means that the probability changes based on what I pick out. So if I start out, you're going to see that I have 3 baseballs out of 2, plus 2 is 4, plus 3 is 7, plus 2 is 9. So 3 out of the 9 pieces of sports equipment are baseballs. After I take that baseball out, I still have 2 kickballs, but now I only have 8 overall pieces of equipment. 3 times 2 is 6. 9 times 8 is 72. That can be reduced to 112. Okay. Since we did not replace them, that is dependent probability. Okay. 2 more for this video. Number 6, a 6-sided number cube has faces with numbers 1 through 6 marked on it. A coin has heads and tails. The dice is rolled and the coin is tossed. What is the probability that the number is greater than or equal to 3 and a heads? So 3 and a heads, those are independent. So look at each probability separately. So greater than or equal to 3 is 3, 4, 5, 6. That is 4 out of 6. Multiply that by a heads, which is 1 out of 2. What I'm going to do as a 4 out of 6 is I'm going to reduce that to 2 out of 3. Now when I multiply, I'd get 2 out of 6, which again can be reduced to 1/3. Okay. Number 7, there are 3 green M&Ms, 2 yellow, 6 red, and 4 blue. What is the probability of picking 2 red without replacement? That is dependent. That is our dependent probability. So 3 plus 2 is 5, plus 6 is 11, plus 4 is 15. So 2 red. So when I start out, I have 6 red out of 15. I take a red out. So I only have 5 red remaining. Took one of the M&Ms out. So there's 5 out of 14 red remaining. Okay. I can multiply that. I'm going to do some cross canceling to make my life easier. First, 5 and 15, and then 6 and 3, and then finally 2 and 14. So what that gives me is equal to, there's a 1 out of 7 chance to get red, and a red without replacing.